Hey guys, so we're finishing the 5.1 notes, and this is where the calculus comes in. The beginning part was basically reviewing what a natural log is, how to expand logs, properties of logs, but here we're actually learning how to take the derivative of a log, and it's actually not a hard formula to know. All you're doing is taking the derivative of the inside, which is represented by du, and you put it all over the inside. It's pretty simple. So all you need to do is recognize what the inside of the log is and then derive it, then put it all over that exact inside. So for number 1 here, the inside's 2x. So derivative of 2x is 2, and you put it all over 2x, and you get 1 over x as your derivative. All right, the next one, all right, we want to derive this natural log. So we locate the inside. You take the derivative of the inside. So the derivative of 3x squared plus 2 is 6x. And you put it all over the inside. And you want to simplify if you can. There's nothing more you can do. Don't be trying to reduce this 6 and that 3. You can't do that because it's attached to something else by addition. Okay, if it's attached to something else by addition or subtraction, you can't just start canceling anywhere you want. The next one here, number 3, if you can, you always want to expand first because that'll make your life easier. I don't want to, like, I'm a calc teacher and I don't even want to derive this with product rule if I don't have to. So what you do is when you can, you expand it first. So we just learned this. When you have the natural log of a product, you do the natural log of the first factor plus the natural log of the second factored. You look to see if it's expanded fully. It's not. This exponent, where does it move? It moves in front. And now this is completely expanded. And now what we do is we take the derivative of each part individually. So the 3 stays there. The derivative of the first log is the derivative of the inside, which is 1, over the inside. Plus the second part here, the derivative of the inside is 5. Over the inside is 5x plus 1. Can't reduce these 5's because this 5x is attached to something else by addition. All you can do is simplify this as much as you can, which would make it 3 over x plus 5 over 5x plus 1. And there you go. There is, whoop, the mouse got stuck. There is the derivative answer. All right, you can't forget your other rules. Can't forget product rule and quotient rule and chain rule. So looking at number 4, what rule would you have to use first here? Yep, you have to use product rule first. So you do, here's my first and here's my second. So first times the derivative of the second. The derivative of the log is the derivative of the inside, which is 5 over the inside. And then plus, this is the second part of product rule, the second times the derivative of the first. Derivative of x squared is 2x. All right, all you can do is clean this up a little bit. The 5's will cancel. The x squared over x reduces to just x. You cannot multiply this 2x into the inside of a log, just like you can't multiply into the inside of a trig function. It just goes out in front. So 2x natural log of 5x. If you want to pull an x out, you can, but you do not have to. Okay, if you want to pull an x out, you can. You do not have to. I would accept either one of these answers. All right, for number 5, what rule do you have to use first here? Yep, quotient rule. So quotient rule says the bottom times the derivative of the top. Now I just noticed here, how can you expand the top to make it easier? You can make it 2 ln of x. So when I do the bottom times the derivative of the top is keep the 2 times the derivative of the natural log of x. This is the derivative of the inside, so derivative of x over the inside. So first part of quotient rule is bottom times the derivative of the top. Derivative of the top is 2 times 1 over x minus the top times the derivative of the bottom. Derivative of 5x plus 2 is 5. And then all over the bottom squared. And now we're going to simplify this. So, all right, this becomes 2 over x. So it's 2 over x times 5x plus 2 minus 10 ln of x. Where did I get the 10? The 5 times the 2. That's an x. That is an x, okay. All over the bottom squared. Now, you can't leave a fraction within a fraction. So to make this a common denominator, all you have to do is multiply this x over to the 10. So that's second fraction. So 2 times 5x plus 2 minus 10x ln of x. I'm finding a common denominator in the numerator. So I'm putting it all over x, that common denominator. And instead of saying all over again, 5x plus 2 squared, that's the same thing as multiplying by 1 over 5x plus 2 squared. What does that do? That just puts it in the denominator. That's it. So we found a common denominator by basically multiplying by x over x for both parts. When you do that, this just becomes 2. On the left, this becomes 10x. And then all over x that goes on the bottom. All right, I'm fine if you leave this answer the way it is. Okay, if you want to multiply the 2 in here, you can do that, but you don't have to. Okay, moving down. All right, number 6. What do you think you should do with this first? Definitely don't want to derive it the way it is right now. You should do what first? Okay, yeah, when you can, you expand it. So the first part becomes 2 ln of x plus, right, because these are multiplied together, so it's addition. The exponent comes out, the natural log of 5x plus 2, or plus 3, sorry. And then anything on the bottom is subtracted, and this is to the 1/2 power, so the 1/2 comes out in front. And now it's much easier. Now you take the derivative of each term separately. So derivative of the first part, derivative ln of x is 1 over x, plus 4 times the derivative of the second part, so derivative of the inside is 5 over the inside, minus 1/2, the derivative of the inside here is just 1 over x minus 2. And now you're going to simplify it as much as you can. So the first part's 2 over x. The second part, 20 over 5x plus 3. And the third part, you can leave it as just 2 parentheses x minus 2, or you can multiply that 2 in if you want. Okay, it's simplified as much as I can, looking up and down. There's nothing more I can simplify. And there you go for that part. All right, now I'm going to teach you logarithmic differentiation. So what we're doing here is taking a complicated looking function and making it easier by throwing logs in. So you look at something, if I gave you this back in chapter 2, you would be able to derive this, but you would have to use quotient rule and chain rule, okay, which is a lot. And it just would require more work, but you'd be more likely to make errors. So if it doesn't have a natural log in it, what you can do is something called logarithmic differentiation, which is putting a natural log in there on both sides. Remember, whatever you do on one side, you need to do on the other side to keep it balanced, the equation. And now what you're going to do is you're going to expand the right-hand side. So I have the steps listed right here. So expand this so the 2 comes out in front. And then because this is on the bottom, we minus. What's the power that comes out in front for the bottom here? It'd be a half. And then the natural log of x squared plus 1. Once it's expanded, now you take the derivative of each term. Now this is the first time you're seeing this. When you take the derivative of ln of y, like we've done before, the derivative of y is dy over dx, and then you put it all over the inside. That's the rule for deriving a log, derive the inside over the inside. You could also write it as y prime over y if you want to. So you're going to solve for dy over dx or y prime, however you want to write it. Some of you think y prime is probably easier to write than dy over dx. It's your choice. We just learned it as dy over dx before, but it's the same thing. So 2 times the derivative of the inside here is 1 over the inside minus 1/2 times the derivative of the inside here is 2x over the inside. All right, and what you're going to do next is you're solving for the derivative. Well, the derivative is either dy over dx or y prime. So to get it by itself, you're going to multiply through by y. You're going to get this to the other side. So you're multiplying everything on the right by y. Simplify it along the way. So it's 2 over x minus 2 minus, look at this. You can cancel this 2 and that 2. So you're just left with x in the numerator over x squared plus 1. All right, and you're basically done. But this is the step that some people forget, and I'm going to let you be lazy. So you want to plug back in for y, which you really want to take this and plug it back in here. But for the sake of saving time, totally okay if you just circle it and draw an arrow showing you know you have to. That's totally fine for this problem. If you want to take the extra second to write it, that's fine. You can just draw an arrow. If you don't circle it and draw an arrow, you're going to get a point off. All right, so you want to make sure that you do that. All right, we're going to practice another one here. Okay, so since it doesn't have a natural log on both sides, you're going to put a natural log in. If it did have a natural log on the right, you would just go into expanding right away, but it doesn't. So we put a natural log in, and then our second step is to expand. So when we expand this, the power comes out in front, so 2 ln of x plus, because you're being multiplied here, 4 ln of 5x plus 3. And then minus, because this is subtraction, the power in front is a half ln of x squared plus 1. And now the next step is to derive. So derivative of y, let's write it the other way this time, is y prime over y, right? Derivative of the inside, which is y prime over y. You can also write it as dy or dx over y. Doesn't matter. Derivative of 2 ln x is 2 times 1 over x. Plus the derivative of the second part here, derivative of the inside, which is 5 over the inside. And the third part here, derivative of the inside over the inside. Okay, and now we have 2 steps left. Solve for y prime, simplify in here. So I notice in here, those 2's will cancel. Nothing else will cancel. Don't try to cancel these 5's. You can't do that. So I want to solve for y prime. So to solve for y prime, I'm going to multiply through by what? By y. And here I'm left with the first term's 2 over x plus 20 over 5x plus 3 minus the second part is x over x squared plus 1. And then what's the very last step that we talked about in the last example? You want to show that supposed to plug in for y. So circle it, plug it back in, and this is your final answer. Right, and the very last type that we're going to look at, we're not going to do relative extreme or points of inflection, is implicit differentiation. We've already done this. We did this in section 2.5, where you leave it as is, it's not solved for y, and you take the derivative of each term, and whenever you're taking the derivative of a y term, you multiply by dy over dx. You can write it as dy over dx, or you can write it as y prime. It doesn't matter. We're going to do one of these. So I'm going to just start deriving right now, just the way it is. So derivative of x cubed is 3x squared, plus the derivative of ln of y is the derivative of y over y, because that's the formula for taking the derivative of a log, derivative of the inside over the inside. You could write it as y prime over y. That's fine too. Plus the derivative of y cubed is 3y squared times dy over dx, or you would write it 3y squared y prime, equals the derivative of a to 0. Now, don't leave fractions, okay? Clear it right away. So we clear it by multiplying everything by y. So that gives you 3x squared y plus 2 dy over dx, because these y's will cancel, plus 3y cubed. Remember, I'm multiplying this y into each term, dy over dx, and then still equals 0. And the whole point is to solve for dy over dx. Anything that doesn't have a dy over dx, you move to the other side. So I move this 3x squared y to the other side by subtracting. And everything on the left has a dy over dx in it. So that means now if we want to solve for dy over dx, what we're going to do is we're going to take it out. So get it by itself by taking it out. And then what are we going to do to both sides to get dy over dx by itself? We're going to divide through by what's in the parentheses. Over 2 plus 3y cubed. And there you go. There's your answer. Okay? You can't simplify anymore. Don't try to cancel these y's. You can't do that because it's attached to something else by addition. Can't cancel these 3's, same reason. So your best bet is, if you're not sure, don't touch it. Because some of you cancel in crazy ways, and it's like bizarre. Remember, you can't do something like this. You can't just cancel. I totally missed the x. You can't just cancel the x's and call that 3. That's like you saying this. 1 plus 3 over 1 is 3. No, it's 4. All right? So don't make up your own rules. When it's attached to something else by addition or subtraction, you can't just go canceling anytime you want. If it's attached by multiplication, yes, you can cancel. All right? So those are the rest of the 5.1 notes. Don't worry about relative extreme error and points of inflection. Just focus on learning how to derive a natural log and doing the logarithmic differentiation technique, which is taking the natural log of both sides like we did here. And implicit differentiation is just extension of chapter 2. Now we just know how to take derivative of a log. That's it. All right. Thanks, guys.